This week we're going to look at two different concepts, and the first one is going to be scientific notation. Scientific notation is this weird thing. So the question is, why do we use it? Why do we need it? So scientific notation is used in science to solve equations with very large or very small numbers. Now we're going to learn this in math that you will then translate later into different mathematics. And you've probably done scientific notation. This should be mostly a review. You may not have seen it though for a while. I know we do this when I teach junior high math, and I'm not positive how long it's been since you've seen it. We will use it a little bit differently when it comes to multiplying and dividing some things, but let's do a quick review. Again, the why for scientific notation is when they're really, really big or really, really small numbers. And sometimes if you have this huge number that you type into your calculator, it may spit out like 3.28, and then it may have this little number with it. Some of them have an E with a number over it, or a 10 with a number over it. And that's your calculator's version of scientific notation. That just means that number is too large for your calculator to compute. And so we use scientific notation to make numbers that are that big or that small, which would be a massive decimal, workable. So that example problem I just gave you is compute 200 times the distance from the Earth to the Sun, which is 93 million miles. Normally, we would just do 93 million times 200. But if I type that in my calculator, which I have right here, 93,000,000 times 200, it's going to spit out, I should have done that before I started recording, it's going to spit out 1.86 with a 10 on top. It's too large to actually compute. And so in my brain, what this looks like is 1.86 times 10 to the 10th power, which is what we're used to seeing scientific notation in. So if we're going to work this out by hand instead of using our calculator to get an answer, what we're going to do is there's going to be a couple of steps. The first step we're going to do is we're going to put it into scientific notation. Scientific notation. Now, it's probably been a while since you've done that, so just a quick review, and if you need me to sort of do another video on this to recap, let me know. Our understood decimal is at the end of the number, and I need to move that decimal, and really, there should be a decimal right here that I forgot to type in. We move our decimal 1, 2, 3, 4, 5, 6, 7 places. So it becomes 9.3 times 10 to the 7th power. On 200, we move it 1, 2 places. So it becomes 2, technically 0.0, but that 0.0 doesn't change anything, times 10 to the 2nd power. And from this point, it's really easy because we just multiply our whole numbers. Because our bases match, we add our exponents. When we are multiplying, remember we add exponents. So we do 9.3 times 2, and then we do 10 to the 7th power, 10 to the 2nd power, so we add them. What we get then is 18.6 times 10 to the 9th power. Now let me write this step in here. We multiply. Now some of these will be division. So what I want you to write down is multiply or divide, D-I-V-I, whoops, the numbers. And I'm going to use just a number symbol. Your coefficients the big numbers don't change the operation. We do what it says to do. If we're multiplying, then we multiply. If we divide, then we divide for our numbers. Now for the exponents have their own rules. When we are multiplying, oh my, that should be an L. Okay, well, let me fix how to spell multiply, because apparently I've lost my mind. When we are multiplying, we add exponents. Are dividing, we subtract exponents. So step one, convert your big numbers, or if they're decimals, technically while they're long, they're a little number, into scientific notation by moving that decimal. Then if you're multiplying, you multiply whole numbers, divide whole numbers, depending on what the operation tells you to do. And then you add or subtract your exponents. Now we do have one little issue with this, because this, you have to have your decimal after the first whole number. So occasionally you may need to do some manipulation. I need this decimal to move from here to here. It has to be after the first whole number. So if I move it one place, I have to go up one place. So technically 1.86 times 10 to the 10th power. Now I'm going to be real honest with you. We are going to do this on this lesson because it's in this textbook, and then we may not see it again for a real long time, because this is one of those things that you use a lot in science when you're dealing with a lot of sciences will use scientific notation, but you're going to cover it again when you get to that point. So we're going to do this lesson, we're going to do the homework, and then we're going to kind of just skip over scientific notation because there are a lot more important algebraic things that we need to cover. So don't stress out about this. We're going to look at it, we're going to cover it, and then we're going to move on. So let's look at two more examples. First of all, let's just kind of review changing numbers into scientific notation. Remember, you want your whole number, nope, that's not the right word. You want your decimal after the first whole number. So I need my decimal to be moved from where it is to here. I'm going to move it 1, 2, 3, 4, 5 places. Now here's the thing. If I am moving my decimal to the right, it becomes a negative exponent. If I am moving my decimal to the left, it is a positive exponent. I moved this, how many places? 1, 2, 3, ooh, lordy, let me erase that and just do it again so I can count it better. 1, 2, 3, 4, 5 places to the right. So it is 5.4 times 10 to the negative 5. Because I moved it, excuse me, to the right, it is a negative exponent. Now here's the problem. I'm not supposed to have a negative exponent. So technically, what I'm going to have, or what I should have, is this. However, for scientific notation, they don't care anymore about negative exponents, and you can leave it with the negative exponent. So what we learned last week about not having negative exponents doesn't apply when you're dealing with scientific notation. So moving to the left, it's positive. Moving to the right, it's negative. Now let's actually do a problem. So we're going to multiply 30 million times 0.00023. Typing this in your calculator, it's not going to compute it. At some point, some of these might become so large it will just say error because it can't compute it. So the first thing we're going to do is we're going to convert both of these into scientific notation. So for that one, I'm going to move this 1, 2, 3, 4, 5, 6, 7. So it becomes 3.0 times 10 to the positive 7, because I'm moving it to the left, times 1, 2, 3, 4, 5, so it becomes 2.3 times 10 to the negative 5th power, because I'm moving it to the right. So step 1, scientific notation. Step 2, do what it says to the whole numbers. I'm multiplying, so I'm going to multiply 3.0 times 2.3. 3.0 times 2.3, and what I get is 6.9. And then I'm going to add my exponents. I'm adding them because I'm multiplying. Now you do need to pay attention to your signs here, because what I have is 7 plus -5, which gives me +2. And that is the answer. So step 1, convert to scientific notation. Step 2, multiply or divide your whole numbers, and then take care of your exponents. If you're multiplying, you add them. If you divide, you subtract them. All right, let's look at one more. Let's do a division one. All right, so step 1, I want to use a different color. I'm tired of looking at that red. So step 1, we're going to convert this to scientific notation. So I'm going to move 1, 2, 3, 4, 5. So my first number becomes 5.0 times 10 to the 5th power, and it's positive because I'm moving it to the left, divided by 1, 2, 3, 8.0 times 10 to the -3rd. It's negative because I am moving it. Oh, that's not true at all. It's not negative. It's positive. All right. Now I'm just going to divide my whole numbers and subtract my exponents. So if I do 5 divided by 8, I get, oh, my pencil quit. I get 0.625. And then I am dividing, so I'm going to subtract 5 minus 3, divide, so I subtract my exponents. 5 minus 3 is 2. Now you do have to pay attention. This is not in full scientific notation form. Remember, where does your decimal have to be? After the first whole number. So technically I need to move it here. Okay, after that first whole number. If I am moving my decimal to the right, I am having a negative exponent. If I'm starting with 2, I am taking an exponent away technically because it's negative. That's going to leave me with an exponent of 1. Okay, now don't get too bogged down in here. Just do your best. This is not some major concept that you're going to have to master for Algebra 2. It's just one of those things that we have to cover. So we're just going to do our best on these. Here's what you need to remember. Scientific notation, then do what it says to the coefficients, or to the big numbers. If you're multiplying, add exponents. If you are dividing, subtract exponents. Here are 6 practice problems I want you to try, and just like we've been doing, I would really like for you to write these down and try them on your own, and then come back and pause the video, work them, and then come back and let's work through them together just to check them and make sure that you are at least somewhat understanding the concept. All right, here's 1 and 2 kind of spread out, so let's work these. The first thing I'm going to do is put these in scientific notation, and when you did this, you should have ended up with this. 10 to the -5th power. Oops, that's a boo. -5th power. All right, so if you did not get that when you did this in scientific notation, go back. Remember, your decimal has to be after your first whole number. If you are moving to the left, you have a positive exponent. If you are moving to the right, you have a negative exponent. Now we're going to multiply our whole numbers, 9.3 times 5.4, which I believe gives me 50.22. And then I am going to add my exponents because I'm multiplying. 7 plus -5 gives me 2. Now there's one problem. This is not in full exponential form or scientific notation form. I have to move my decimal 1 place to the left, so it is a positive. So technically, my answer, I'm moving it to the left, so it's a +1 or a +1, so my exponent becomes 3. All right, let's look at this next one. When I translate this into scientific notation, I should have 1.8 times 10 to the 4th power times 7.0 times 10 to the 3 power. I'm multiplying, so I just multiply whole numbers. 1.8 times 7.0 is 12.6. I am multiplying, so I add my exponents. 4 plus negative 3. 4 plus negative 3 is 1. But I have another problem again, not in full scientific notation. So I'm going to move my decimal one place. I'm moving it to the left, so it is a positive 1. Positive 1, and I had 1. I now have 2. All right, let's look at 3 and 4. All right, 3 and 4. So when I put this into scientific notation, I should have had 6.4 times 10 to the 5th power. Wait, 1, 2, 3, 4, 5. Yep, okay, my brain thought I did it wrong. And now this one is going to be 9.2 times 10 to the negative 1 power. Still multiplying, so I'm going to multiply my whole numbers. And I am going to get 58.88 times 10. 5 plus negative 1 is 4. But not in full form, so I'm going to move my decimal one place to the left, which means it is a positive, which means I'm going to go from 4 to 5. All right, let's do these last three, which are division. My first step is the same. I'm going to convert to scientific notation times 10 to the 4th divided by 4.0 times 10 to the negative 2. I am dividing, so I'm going to divide my whole numbers this time. When I divide them, I get 0.31. I am dividing, so I'm going to subtract these. Now watch this. I have 4 minus negative 2. Minus and negative becomes a plus, so it becomes 10 to the 6th power. But not in full form. So I've got to move my decimal one place, but this time I'm moving it to the right. When I move it to the right, it becomes a negative. So instead of a 6, I'm going to take 1 away because I have to move it negative 1, so it becomes 5. Let's look at the next two. Let's work number 6 first and then come back and do number 5 because it's multiple steps. It's a little bit different. So the first thing I'm going to do is convert this to scientific notation, and I end up with 5.8 times 10 to the negative 4. And then I have 2.3 times 10 to the negative 3. Oh, that's a weird parenthesis. Now, I'm multiplying. Make sure you watch those signs. Sometimes when we're sort of doing the same problems over and over and over, we kind of overlook and get mixed up because we're just not paying quite enough attention. So make sure you're watching your operations here. 5.8 times 2.3 gives me 13.34. Now I'm going to add. Watch your signs. Negative 4 plus negative 3 is negative 7. But not in the right form. Move it to the right one place, so that is a positive. So if I have negative 7 and I now have a plus 1, I end up with negative 6. Technically, this is the correct value. It's just not quite in the simplest form. Now let's come up to number 4. Because technically this is a two-step thing. Within the steps we're already doing. So step 1, convert this, oops, that should be a decimal, not a comma, which I guess doesn't look much different on this pen, times 10 to the 4th power, times 3.0, oops, times 10 to the 3rd power, divided by 6.0 times 10 to the 1st power. And the truth is, you could probably type this one in your calculator and get a sufficient answer, but they want you to do one like this. So what we're going to do is we're going to do this whole numbers 4.0 times 3.0 divided by 6.0. When we do that, we get 2. 4 times 3 is 12. 12 divided by 6 is 2. Now we're going to add these exponents because we're multiplying. 4 plus 3 is 7. Take 1 away because we're dividing that one. So 7 minus 1 is 6, and that is it. All right, again, don't stress over this. It's weird, and we're not going to be super duper concerned. However, there are some problems that require you to use this, I think, on some of your homework. So let's just do one more of those. Well, we're not actually going to work it, but I do want to show you something. If you have a problem like this, it's a 5, by the way, and not an S. Let's just say, here's what you need to remember. This fraction line means divide. So you're still going to do what we just did. You're going to convert everything to its scientific notation. Then you're going to just use your order of operations. Multiply this, then divide by this. And I'm not positive you have those in your homework, but I feel like I remember seeing one like that. So when you get to those homework problems, just do your best.